going to be talking about basically the same materials here. The difference is I use different metal. As Andrew already told us, the mask is a metal-organic supercontainer. And here is, because due to the size of the molecule, we choose to use much smaller, the complex, TNC complex. You can see the graph is reading here. It's also made by Wendi. You can see the metal, the metal atoms is incorporating with the oxygen atoms, making a complex here. I'm going to first discuss a little bit about the total energy here, as the situation is the same. We have the lowest energy with the case of the average spin state, and the highest energy with the N up down equal when it's equals to 12 is the high spinning state. I'm sorry. The lowest energy is actually on the lowest low spin state, and this is what I found is different from Andrew's presentation. And interestingly, I looked into detail about the electrons from the outcard file, and we could see that the states here are different. After you use this code to run through the basket, the high and low spin states, they have different total number of states. And here, that's why we think the system takes it in average, because the number of electron is not here. Doesn't show the integer here. But if you add this up, the total number of electron is same. It's same with 314. And more interestingly, I found out that in the low spin case, it has less electron spinning up than in this case, which is high spin case. So that might help explaining the following graphs. Next, I looked into the density of states, and it has the same tendency as the Andrew showed us, which this is the average one, and this is the high state, high spin case, and in the low spin case here, the energy, the orbital energy of spinning down is more than the orbital energy of spinning up, the alpha spin. And in the contract, reversely, in here, the energy, the situation gets reversed. You see, there's more orbital energy here, and that might be because of the increased electron spinning up in the high spin situation. And the absorption spectrum, I found out there's a peak around 500 to 600. That might be the green color. So most of the green color gets absorbed, reflecting the dark red color. I assume that the cobalt is most likely dark reddish color. And this is the orbital, HOMO and LUMO orbital. The green one is HOMO at the states of 158, and the blue one is LUMO. These are just some p octal of the carbon, which we might not care. Here is you can see the octal of the cobalt, the metal. And as I conclude, the total energy of average high spin and low spin are pretty much close. High spin molecule has relatively high total energy. On the other hand, low spin molecule has lowest total energy. And this comparison, compare cobalt to nickel, we could see this absorption spectrum, I guess it's based on the different characteristic of cobalt and nickel, because everything else is the same except for the cobalt and nickel. And for this part, as you already seen before, I think the tendency is the same. The average is pretty much even. The alpha spin and the beta spin. And after that, in the high state, you have more alpha spin, more energy of alpha spin. Sorry. And that's it. Thank you.
Okay. Thank you.